In this session, we will discuss the systems development lifecycle in the relationship to nursing informatics and organizational decision-making. At the end of this session, you will be able to describe the systems development lifecycle, assess interoperability and its importance in addressing and meeting the challenges of implementing the HITECH Act in healthcare. The Systems Development Lifecycle, or SDLC, is a way to deliver efficient and effective information systems that fit with the strategic business plan of an organization. The business plan stems from the mission of the organization. In the world of healthcare, its development includes a needs assessment for the entire organization, which should include outreach, linkages, and partnerships in merged or shared functions. The organization's participating physicians and other ancillary professionals in their offices are included in a thorough needs assessment. When developing a strategic plan, the design must take into account the existence of the organization within the larger healthcare delivery system and assess the various factors outside of the organization itself, including technological, legislative, and environmental issues that impact the organization. The plan must identify the needs of the organization as a whole and propose solutions to meet those needs or a way to address those issues. SDLC can occur within an organization. It can be outsourced or be a blending of the two approaches. With outsourcing, the team hires an outside organization to carry out all or some of its development. Developing systems that truly meet business needs is not an easy task and is quite complex. Therefore, it is common to run over budget and miss milestones. The waterfall method is one of the oldest methods and literally depicts a waterfall effect. That is, the output from each previous phase flows into or becomes the initial input for the next phase. This model is a sequential development process in that there is one pass through each component activity from conception or feasibility through implementation in a linear order. The deliverables for each phase result from the inputs and any additional information that is gathered. There is minimal or no iterative development where one takes advantage of what was learned during the development of earlier deliverables. Many projects are broken down into 6 phases, especially small to medium-sized projects. As technology advances and faster development is expected, rapid prototyping, also known as rapid application development, provides a fast way to add functionality through prototyping and user testing. It is easier for users to examine actual prototypes rather than documentation. A rapid requirements gathering phase relies on workshops and focus groups to build a prototype application using data. The prototype is then beta tested with users and their feedback is used to perfect or add functionality and capabilities to the system. According to Alexandro in 2010, RAD, or Rapid Application Development Process, proposes that products can be developed faster and of higher quality. The Rad approach uses informal communication, repurposes components, and typically follows a fast-paced schedule. Object-oriented programming, such as languages as C++ and Java, promotes software repurposing and reuse. The major advantage is the speed at which these systems can be deployed. A working, usable system can be built within 3 months. The use of prototyping allows the developers to skip steps in this SDLC process in favor of getting a mock-up in front of the user. At times, the system may be deemed acceptable if it meets a predefined minimum set of requirements rather than all of the identified requirements. This rapid deployment also limits the project's exposure to change elements. Unfortunately, the fast pace can be its biggest disadvantage in some cases. Once one is locked into a tight development schedule, the process may be too fast for adequate testing to be put in place and completed. The most dangerous lack of testing is in the realm of security. The Rad approach is chosen because it builds systems quickly through user-driven prototyping and adherence to quick, strict delivery milestones. This approach continues to be refined and honed, and other contemporary manifestations of RAD continue to emerge in the agile software development realm. The Object-Oriented Systems Development, or OOSD model, combines the logic of systems development lifecycle with the power of object-oriented modeling and programming. Object-oriented modeling makes an effort to represent real-world objects. By modeling the real-world entities or things, for example, hospital, patient, account, nurse, into abstract computer software objects. Once the system is object-oriented, all of the interactions or exchanges take place between or among the objects. The objects are derived from classes, and an object consists of both data and the actions that can be performed on the data. Class hierarchy allows objects to inherit characteristics or attributes from the parent classes, which fosters object reuse and results in less coding. The object-oriented programming languages such as C++ and Java promote software repurposing and reuse. Therefore, the class hierarchy must be clearly and appropriately designed to reap the benefits of this Sdlc approach, which uses hand-object-oriented program to support the interactions of objects. The class hierarchy from which all of the system's objects are created with resultant object interactions must be clearly defined. The OOSD model is a highly iterative approach. The process begins by investigating where object-oriented solutions can address business problems or needs, determining user requirements, designing the system, programming or modifying object modeling, implementing user testing, modifying, and implementing the system, and ends with the new system being reviewed regularly at established intervals and modifications being made as needed throughout its life. The Dynamics Development System, DSDM, is a highly iterative and incremental approach with a high level of user input and involvement. The iterative approach or process requires repetitive examination that enhances detail and improves accuracy. The DSDM has 3 phases: pre-project, project, or project lifecycle, feasibility, business studies, functional model iteration, design and build iteration and implementation, and post-project. In the pre-project phase, commitment or phased buy-in is established and funding is secured. This helps to identify the stakeholders, administration, and end users and gain support for the project. In the second phase, the project's life cycle begins. This phase includes 5 steps: 1, feasibility; 2, business studies; 3, functional model iteration; 4, design and build iteration; and 5, implementation. In steps 1 and 2, the feasibility and business studies are completed. The team ascertains if the project meets the required business needs while identifying the potential risks during the feasibility study. In step 1, the deliverables are the feasibility report, project plan, and a risk lodge. Once the project is deemed feasible, step 2, the business study is begun. The business study extends the feasibility report by examining the processes, stakeholders, and their needs. It is important to align the stakeholders with the project and secure their buy-in because it is necessary to have user input and involvement throughout the entire DSDM process. Therefore, bringing them in at the beginning of the project is imperative. When reviewing Sdlc, the computer-aided software engineering or CASE tools that will be used must be described. CASE tools automate many of the tasks required in the system's development effort and encourage adherence to the Sdlc, thus instilling a high degree of rigor and standardization in the entire system's development process. These tools help reduce cost and development over time while enriching the quality of the product. CASE tools contain a repository with information about the system, models, data definitions, and references linking models together. They are valuable in their ability to make sure the models follow diagramming rules and are consistent and complete. The various types of tools can be referred to as uppercase tools or lowercase tools. The uppercase tools support the analysis and design phases, whereas the lowercase tools support implementation. The tools can be general or specific in nature, with the specific tools being designed for a particular methodology. Another area that must be discussed with systems development lifecycle is open software, or open source software, OSS. An examination of job descriptions or advertisements for candidates show that many IS or IT professionals need a thorough understanding of SDLC and OSS development tools. For example, PHP, MySQL, and HTML. With OSS, any programmer can implement, modify, apply, reconstruct, and restructure the rich libraries of source codes available from proven, well-tested products. As Valdez 2008 notes, examples of OSS successes are the Internet, Google, Web 2.0, the new Linux operating system, courseware such as Moodle, and the Veterans Affairs Vista Hospital system. To transform healthcare, it is necessary for clinicians to use information systems that can share patient data. This all sounds terrific, and many people wonder why it has not happened yet, but the challenges are many. How does one establish the networks necessary to share data between and among all healthcare facilities easily and securely? Healthcare IT is beginning to adopt open source software to address these challenges. Early attempts at open source software ventures in the healthcare realm failed because of a lack of support or buy-in for the sustained effort, technological lags, authority and credibility, and other such issues. Spurred by a greater sense of urgency to adopt IT, health industry leaders are showing renewed interest in open source solutions. Healthcare is realizing the benefits of OSS. According to Gould and Brown, other benefits of open source software, low cost, flexibility, opportunities to innovate are important, but independence from vendors is the most relevant for healthcare. Interoperability, the ability to share information across organizations, will remain paramount under the HITECH Act. The ability to share patient data is extremely important both within an organization and across organizational boundaries. According to the Health Information Management Systems Society, HIMSS 2010, few healthcare systems take full advantage of the full potential of the current state-of-the-art in computer science and health informatics. The consequences of this situation include a drain on financial resources from the economy, the inability to truly mitigate the occurrence of medical errors, and a lack of national preparedness to respond to natural and man-made epidemics and disasters. HIMSS has created the Integration and Interoperability Steering Committee to guide the industry on allocating resources to develop and implement standards and technologies needed to achieve interoperability. As we enter into SDLCs, we must be aware of how this type of development will affect both our own healthcare organization and the healthcare delivery system as a whole. In an ideal world, we would all work together to create systems that are integrated within our own organization while having the interoperability to cross organizational boundaries and unite the healthcare delivery system to realize the common goal of improving the quality of care provided to consumers. At times during the SDLC, new information affects the outputs from earlier phases, and the development effort may be re-examined or halted until these modifications can be reconciled with the current design and scope of the project. There are times that teams are overwhelmed with new ideas from the iterative SDLC process that result in new capabilities or features that exceed the initial scope of the project. Astute team leaders preserve these ideas or initiatives so they can be considered at a later time. The team should develop a list of recommendations to improve the current software when the project is complete. This iterative and dynamic exchange makes the SDLC robust. As technology and research continue to advance, new SDLC models are pioneered and introduced to enhance techniques. The interpretation and implementation of any model selected reflects the knowledge and skill of the team applying the models.